A black hole. The single most powerful force in the universe. Nothing can escape a black hole, not even light. But how do these monsters form? Where does their power come from, and what are their effects? In order to understand black holes, you must understand Einstein's theory of general relativity. Einstein postulated that any object with mass will create its own gravitational pull and therein bend space-time. This concept is crucial to understanding black holes, but will be made more apparent later. Before there's a black hole, there's a star. This star is not just any star. It must be at least 2 to 3 times as massive as our own sun. Within that star, there are 2 forces at play: the outward force of energy generated by nuclear fusion and the inward force generated by gravity. Nuclear fusion is what produces the immense light that comes from stars. In the core of the star, hydrogen atoms are being slammed together so hard that they form a helium atom and energy. That energy is called a photon and eventually is the light produced by the star. But this process is so powerful, without gravity to counteract it, stars would just explode with the force of millions of nuclear bombs. But, due to its massive size, this star will have immense gravity that is battling nuclear fusion. After millions, sometimes billions of years, the star finally runs out of hydrogen atoms that can be used for nuclear fusion. At that moment, gravity wins the war and crushes the star inward towards its core. The rebound energy of the core's collapse causes the remaining gas on the outside of the star to explode in a supernova. What is left behind is compressed to a core that may vary in size, but can be as small as just 10 miles across. That is the equivalent action of crushing the Earth into the size of a golf ball. That core, if massive enough, becomes. Imagine that this apple is a planet like Earth and this blanket is space-time. When this apple is placed on the blanket, there's a small dent, but nothing significant. Imagine that this watermelon is a star like our sun. When it is placed on the blanket, there's a sizable change, but it's not too major. This pumpkin represents a black hole. Pumpkins do not have the same gravitational pull as a black hole, so it's not as realistic, but this picture illustrates what really should happen. This is what a black hole does to space-time, and this has some weird effects. If you saw a black hole, it would appear as though its edges were rippling and unstable. This is because space is being bent so far that its existence in space is not constant. If you watched something fall into a black hole, it would appear to slow down as it got closer to the actual hole, or event horizon. This is because time is being bent so severely, is moving so slowly, that it would appear to have stopped. That is why black holes are the true anomalies of the universe. They take all the laws of physics to their limits. Thank you for watching, and I hope this gives you a better understanding of the dark monsters in our universe.